can say RAM and a ROM memory are combined and placed together at the same place. This in the von Neumann type architecture. And in the processor unit contains of course a controlling unit as well as the ALU. Controlling unit is responsible controlling generating a controlling signals, or what I can say other signals which are mandatory. ALU is doing its arithmetic as well as a logical operations. Okay? These are the same which I have explained about this particular one. Central processing unit fetches the instruction from the memory. To process the instruction, CPU fetches the instruction from the memory, and here apart from this memory, IO device and CPU, IO device and other parts, CPU is having other types of registers like that is a program counter. These are all the special type of registers: program counter, instruction registers, as well as a general purpose type. Okay, now we discuss about the Harward type architecture. Again, Harward is another type of architecture which was designed by a scientist called Howard Mark I. Okay? And basically this architecture, when we talk about the von Neumann and the Harward architecture, the difference between these two is that in a von Neumann architecture we have placed program as well as a data memory at the same place, but here we have kept separate program memory as well as a separate data memory. The rest of thing here is the same. When we talk about the sharing the information from the memory to the processor, here I can share a program as well as a data information which are placed in the program as well as data memory parallelly with the CPU. But in a von Neumann type of architecture, I can share either of a program memory, either of a program as well as a data information which I have placed. I can't share both the program as well as the data information at the same time. This is the major difference between the von Neumann as well as the Harward. And we can design any applications according to our need of a memory by considering the von Neumann as well as by considering the Harward type. This is the same which I have explained. In a computer using a Harward architecture, the CPU can read both instruction and performs a data memory access. As I told, I can read both the instructions, that is from the program memory as well as from the data memory, and I can perform the task according to the CPU. Okay? So one more thing I can say here is a Harward architecture computer can thus be a faster for giving a circuit complexity because fetches and the data access do not contend for a single memory pathway. What I can say here is Harward architecture is comparatively faster by comparing with the von Neumann type. The reason here is I can fetches and I can access the data independently from the program memory as well as a data memory. That's why it is a faster we consider. Okay? Next we see a comparison of this architecture, that is a von Neumann as well as a Harward. When we talk about the von Neumann type of architecture, in our von Neumann architecture, data bus and the address bus are not separate. As I told, data bus and the address bus are not separate because we are having only one block of memory. In that only we have placed the program as well as the data memory. And when we talk about the Harward type of architecture, the address and a data buses are separate. Here the address and the data buses are separate so that I can access a content of the program memory as well as the content of a data memory in parallel. The next difference here is it allows storing or modifying programs easily. This is the advantages of a von Neumann type. Okay? It allows storing and modifying of a program easily. But here modifying a program is bit difficult. In a Harward type, modifying a program here is bit difficult. The third difference here is microcontrollers with von Neumann architecture are called a CISC controller. We'll discuss what is a CISC again. As I told, microcontroller with the von Neumanns are called a CISC type, and a microcontroller with the Harward are called RISC type. We discuss what is the CISC and what is a RISC. Next one is in a von Neumann type of architecture, time division multiplexity is used for fetching a program as well as a data. Here we use a time division multiplication in a von Neumann type, but in a Harward type of architecture, as there is a separate program memory and a data memory, there is not necessary to use a time division multiplexing. The next difference here is it needs a multiple fetches for a processing an instruction. It need in a one number it needs a multiple fetches for processing an instructions, but in a Harvard type its internal organization is such that instruction can be prefetched as well as decoded while multiple data are being fetched. Instruction can be prefetched as well as decoded while a multiple data is being fetched. Okay, now we discuss about the what is the RISC and what is the CISC. Basically, RISC and CISC are these architectures. They have classified by considering the types of instructions. That is nothing but these architecture we have classified by considering the types of instructions. When we talk about the CISC, CISC here is nothing but a complex instruction set computer. It is a complex instruction set computer. As per its name, this type of architecture or a system is having a complex instructions and very a large number of instructions. The ranges from the approximately 120 to 350 number of instructions will be there in a CISC type architecture. Even though it is a complex, many companies like Intel, AMD, PC uses this type of architecture. But there are some advantages also by using this type of architecture. That is, by designing any application with this type of architecture, it becomes a fast. What I can say, the implementation of this particular architecture becomes a faster, and the second one is the program space required is less. That is, the implementation here is a faster, and the second place is a program space required here is a less. Now let's discuss about the what is the RISC. RISC here is nothing but the reduced instruction set computer. As I told, as it's according to its name only, it says it is having a reduced number of instructions. That is, the number of instructions supports a RISC is less than 100, and the philosophy behind it is that RISC chips require a fewer transistors to design, which makes them cheaper to design and produce. As it is having a less number of instructions, automatically this type architecture requires a fewer transistor to design. Automatically the cost I can reduce by considering this type of architecture. In one more thing here is each instruction is of a same length so that it may be fetched in a single operation. When we talk about the CISC type of architecture, their instruction are a variable. Instruction length is variable in a CISC type, but here in a RISC type, each instruction here is of an same length. And the next one is, okay, let's we discuss a comparison of a CISC and a RISC according to the architecture characteristics. When we talk about the instruction format, as I told, CISC is having a variable format, instruction with the variable formats. That is, it supports a 16 to 64 bits per instructions, and whereas when we are talking about the RISC type, it is a fixed instruction format, that is of 32 bits. But when we talk about the number of instructions, as I told, CISC supports approximately 120 to 350 number of instructions, whereas RISC supports a less than 100. When we talk about the addressing modes, CISC supports 12 to 24 addressing modes, whereas RISC is having a limited addressing modes, that is 3 to 5. When we talk about the general purpose registers, CISC supports 8 to 24 general purpose registers, whereas RISC is having a large number of general purpose registers. These are ranges from 32 to 192. And when we talk about the pipelining, no pipeline or a less pipeline, because here it is difficult to pipeline architecture. The reason here is this type of architecture are based on the von Neumann type. That's why there is a no or a less pipeline. When we talk about the RISC type, it is highly pipelined. Okay? And when we discuss about the register set, CISC supports a single register set, whereas a RISC supports a multiple register set. When we discuss about the instruction execution, instructions are executed by a microprograms. In a CISC, instructions are executed by the microprograms, whereas in a RISC instructions are executed by the hardware. As it is instruction executed by the hardware, automatically this architecture becomes a faster. When we talk about the complexity regarding the both CISC and the RISC, CISC is having a complexity in a microprogram, whereas RISC is having a complexity in the compilers. Okay. Today we have discussed about the microcontrollers, processor, different types of architecture based on the based on the arrangement of the memory, as well as a comparison of a RISC or a CISC. If you have any questions, you can please ask. Okay.